Let's take a look at a few examples of different kinds of triangle problems you may encounter and sort of talk about the different tricks or ideas that we can use to find missing variables in these problems. Now, all of these are a little bit different, so you may want to watch all the examples just to get an idea for the different things you may want to try based on sides and angles when dealing with triangles. So one of the most basic things, ideas that we'll try, is they'll give you two angles that are congruent to each other. I know they're congruent because the tick marks tell me that. Well, what they then show me or ask me to find are things dealing with sides, and so at first it's like, well, what do sides have to do with angles? But like we talked about in class, if you have two congruent angles in a triangle, it means you also have two congruent sides. Specifically, the two sides across or opposite from those angles will be congruent. So I know I can add some tick marks in there, and I can say that those two sides are for sure equal to each other. So it doesn't really matter what the angles are, as long as they're equal to each other, I'm going to know that these two sides are also equal to each other. They're also congruent. So there's my equation. From there, some hopefully basic algebra to solve. So I'll subtract 3 from both sides and divide by 4. X must be equal to 3. So there's one idea we might try. Two angles that are congruent leads to two sides that are also congruent. Next up, this one may look very similar. We're given two sides that are congruent, so as we talked about, that also is going to imply that two angles are congruent to each other. In other words, those two angles should be equal to each other, and that's true, but if you look closely, one's got an x and one's got a y. So unfortunately, putting them equal to each other won't get us anywhere. So instead, we need to try something else. Well, I'm noticing this top angle is 98 degrees. Now, that doesn't mean the bottom ones are 98. In fact, they couldn't be, otherwise that would add up to more than 180. But I can use this fact to help me find what those angles at the bottom of the triangle are equal to. Since I know the sum of all three is 180, let's subtract off the one angle that I do know. So 180 minus 98 leaves me with 82 degrees. So those two bottom angles must total 82 degrees. Which doesn't really get me any further until I remember that those angles are also congruent to each other. So that 82 has to be evenly split between each of those angles, meaning each individual angle is 41 degrees. So let's use that fact to find x and y. So I'm actually going to set up two separate equations since I have two variables to work with. So 5x plus 6 has to equal 41, as well as this angle over here, y minus 9 has to also equal 41. So two separate equations to solve, two separate answers. So y's got to be 50 if I add 9 to both sides. For the x, if I subtract 6, I'd be left with 5x equals 35, and divide, leaving me with x equals 7. So there's something else we may want to try to find missing variables in these triangle problems. Our next example is actually going to use two different kinds of triangles, and so what I want to do is I want to focus just on this triangle that I'm outlining in blue. So let's just look there for right now, and so we'll find y first. What I notice is that this time I have all three angles the same, which means all three sides are also the same. Kind of an extension of that idea we just talked about. If you have two equal sides, you have two equal angles. Well, if you have three equal sides, you have three equal angles, and vice versa. So really I'm dealing with an equilateral triangle, meaning all sides are the same length, and since I can see one of them's labeled 4, well, all sides have to be 4. Well, that's easy then for y. Y is 4. Okay? So it's an easy idea once we kind of break this apart and look at different parts of the triangle. Let's take a look now at the lower part, so the part I'm outlining right now in yellow. So this time I can see that I'm dealing with, well, two congruent angles, so those two bottom angles are equal, meaning I've also got two equal sides. The sides opposite those angles have to be congruent as well. So this bottom triangle, let's say I'll put double tick marks on there if you can see them, this bottom triangle is really an isosceles triangle. I have two equal sides. One of them is labeled x plus 1. But it's got to be equal to the side we already know is 4 from that equilateral triangle. So subtracting 1 from both sides, I find out that x is 3. So there's an example dealing with equilateral, equiangular, and isosceles triangles all rolled up into one. And for my last trick, let's take a look at this triangle. Once again, I can see that I'm dealing with an equiangular triangle. All the angles are congruent to each other, meaning all the sides are also congruent. So I also have an equilateral triangle. Well, let me just give you one piece of warning with this problem. I see this happen a lot. People see all three sides labeled, and so they think, well, all three sides add up to 180. But be really, really careful, because it's not sides that add up to 180, it's angles that equal or add up to 180. So be very, very careful about that. If you're dealing with sides, you're not going to be working with 180. Instead, let's go back to, what we said at the beginning of this problem. All the sides are congruent to each other. So I actually have several ways I can set this problem up. Since I know all the sides are equal, let's just take one of the sides. I'm going to pick 7x plus 2 and put it equal to another side. I'm going to use the 2x plus 17. Now it shouldn't matter. Since all the sides are the same, I could have set this problem up very differently using two different sides. I picked those two because the numbers seem smaller to me. So that's why I went with that. From there, let's go ahead and solve algebraically to find out what x is. So subtract 2x from both sides. I'm left with 5x. I'm going to subtract 2 as well to get my constant separated. So if 5x equals 15, that means x must equal 3. A great way to check your work would be to plug that 3 back in for x and see that all sides do come out to be the same thing.